Number 12, define the greatest common divisor. You take the smaller number and divide it into the larger number. So it goes in 2 times, and carefully multiply and carefully subtract, because now the remainder becomes the divisor and the divisor becomes the dividend. And then you repeat this process until you have a remainder of 0. So since we have a remainder of 0, it's not the quotient, it's what you were dividing by that is your greatest common divisor. So the answer is choice C. So, modular congruence. You're looking for a common divisor for 6 and 15. So I can divide by 3. And I also have to take a look at the greatest common divisor of 3, which is the divisor for the problem, and 9. And we see that the greatest common divisor of 3 and 9 is 3. So we do change the mod. This now will become mod 3. And I have 2x is congruent to 5 mod 3. Now looking for a common divisor of 2 and 5, they're relatively prime. So therefore I add on the mod, because there are other numbers in mod 3 that are congruent to 5. So I have 2x is congruent to 8 mod 3. Dividing by 2, and the greatest common divisor of 2 and 3 is 1. They're relatively prime. Therefore, the mod remains at 3. And we have x is congruent to 4 mod 3. Now in mod 3, or clock arithmetic, I have remainders 0, 1, and 2. 4 is not a remainder. So I can go around the clock 0, 1, 2, 3, 4, and see if I start at 0, 1, 2, 3, 4, or if I can subtract 4 minus 3, I'm going to get 1. So I'm starting 1, 2, 3, 4, and I have x is congruent to 1 mod 3. Therefore, I'm going to start the solution set at 1. 1 plus 3 is 4. 4 plus 3 is 7 to generate the first 3 solutions. It does not start at 4 because 1 is also a solution, and you have to start at the smallest solution, the first 3 solutions that satisfy this congruence. So we're going to find the truth value of this statement. Given that P is false, Q is true, R is false. So not P then must be true. And in the parenthesis, we have P, which is false, or we have not Q, which is false. Now, in an or statement, one of the two must be true for it to be true. And neither one is true. So we have T and F for the first part of this conditional. And in an and, they both have to be true for it to be true. Therefore, this is false. Now, continuing the rest of the way, we have Q, which is true, or not R, which is true. Now here, one or both of them must be true, therefore it's true. And T implies F is a true conditional, because the only time a conditional is false is when you have a true hypothesis and a false conclusion. Therefore, the answer is A. Number 15 is the negation of a conjunction. And by De Morgan's, you're going to negate the first part. So this course is not interesting. or you have to change the and to an or I did not learn a lot. So there are two parts to De Morgan's. Not interesting, or that you did not learn a lot. And that would be choice C.